Hey there! Welcome to your first official lesson of Grade 12 Applied Math. I hope it feels great. I'm pumped about it. Before we dive into our lesson, I just want to identify a few things here. You'll notice that we have 1.1 simple interest notes. All of this is in the Classroom OneNote. Another thing about it is that say you lost your copy of the empty notes, you can just double click here and you can download another copy to print in the library or at home. All right, let's launch in. So yesterday we talked about, or I gave you a worksheet matching up different terms, but let's just write down the definition of interest. What is it? Interest can be two different things. It's either on an investment or a loan. So interest is the amount of money earned on an investment. Or it's paid out on a loan. In this unit, Unit 1, we're just going to be focusing on investments. Next unit will be on loans. Now we have two different kinds of interest. You'll see the one that we're focusing on today, simple interest. Let's take down the definition of that. So simple interest is interest that is paid or earned only on the principal. Only on the principal. Now there's another kind of interest which we will deal with tomorrow, but I just want us to take down this definition so that we can have it in the back of our minds. We have compound interest. And compound interest is interest that is earned or paid on both the principal and the interest that you earn. And the interest that you earn is called accumulated interest. Ooh. So on both the principal and accumulated interest. Now we're going to have more fun with that tomorrow, but just have that in the back of your head. So let's go on to the first example. So example 1, Juan invested $4,500 in a guaranteed investment certificate, or a GIC, you know what that is from yesterday, at 1.5% simple interest paid out annually with a term of 3 years. So create a table of values to show how much the investment is worth after 3 years. So it's really easy with the first year. The initial investment is just $4,500. But what happens after the first year? So the original amount is $4,500. And let's talk about this interest earned. Remember, in simple interest, interest is only earned on the principal. So we need to figure out what 1.5% of 4,500 is. Now here's a little flashback from the past. What we need to do is we need to put that into decimal form. Now I bet a lot of you will want to say 0.15, but guess what percentage that is? You got it, that's 15%. So to get 1.5%, it's actually 0.015. Now to find out a percentage of anything, you take the thing that you want to find the percentage of. So in this case, our 4,500, and you multiply it by that decimal of the percent, so 0.015. When we put that in our fancy dancy calculators, that is $67.50. So that means at the end of the first year, the total amount is the interest. Oh, sorry about that. The interest plus the value of the investment. So when we add $67.50 to $4,500, we get $4,567.50. So $4,567.50. What happens the next year? Well, remember, in simple interest, we're just accumulating interest, or we're just calculating interest on the amount, the principal amount. So again, we're finding out what 1.5% of 4,500 is. And lo and behold, it is still $67.50. When we add that to the amount invested after the total amount of the investment after the first year, we get $4,635. We don't even have to do any of this fancy dancy work here. What do you think this is going to be? Well, we're just getting the interest on the original investment. So we know that the original investment here is $4,500. We know that the interest earned is going to be $67.50. So we can just add that $67.50 to the amount, the interest, the value of the investment after 2 years, and we get $4,702.50. So this is the amount that it is worth after 3 years. The question goes on to ask, what is the total amount of interest earned? Well, the total amount of interest earned is the total value of the investment. We're going to call that our future value, and I'm going to say FV, minus the amount originally invested, which is the principal. So our future value here is going to be $4,702.50 minus the principal, which is $4,500, and we're going to get the total interest earned being $202.50. So let's put what we have learned actually into a formula. So our formula here for simple interest is going to be the interest accumulated equals the principal times the rate, the interest rate, times time. Now time is always in years, so where I is interest earned, P is the principal, R is the interest rate, as a decimal, and T here, this is the new thing, T is the time, and it's always going to be in years. Now here's the thing, folks, sometimes we're not going to be given time in years. So what happens if you're given in months? Well, what you want to do is you want to take the number of months and you want to divide it by 12, because that gives us a fraction of a year. So if it's 6 months, 6 divided by 12 is 0.5. Now we know that 6 months is half a year, so you might not have to do that calculation. But what happens if time is given in days? Think about it. Why don't we take the number of days and divide by 365. I'm going to get all nerdy on you for a moment. We all know that there's leap years, so if you really wanted to get a true value, it could be 365.25. But we're not going to get that nerdy. We're just going to use 365. So we as mathematicians like to express our data in a whole bunch of different ways. So why don't we make an investment versus time graph using the data from example 1. So remember the first variable mentioned, so the value of the investment goes on the y-axis, which is the up and down. And the second variable, or time, goes on the x-axis, which is horizontal. Now what I've done is I've already added my little axes here. So let's just go back and flip back to up top here. We know that after the initial value of the investment is 4,500, then we go up by 67.50 every single time. So after 1 year, we're going to have, I'm just going to, just so I can save myself a little bit of time, we're going to say total investment in dollars, so I don't have to put my dollar sign every single time. So 4,500, 67.50. Then we have 4,635, and then we have 4,702.50. Now what we want to do is we just want to add 67.50 all along, because it follows that. It's a linear sort of relationship. So when I add 67.50 to the total value of the investment after 3 years, I get 4,770. And then if I add another 67.50, I get 4,830. Sorry, I put my decimal in the wrong place. 50. So 4,837.50. Now let's do a real good job of labeling our graph here. Okay, so let's just zoom in here. So my x is going to be time in years, and I'm going to go from 0 to 5. 0, 1, 2, 3, 4, 5. Remember, I can't go 0, 2, 3, 7, 10. It has to go up linearly, just like my y-axis. So I'm going to go give a little bit of a, oh, where are you going? Which means we're not starting at 0, we're actually going to start at a greater number. So we're going to put 4,500 here, and every single time we go up, we're going to go up 67.50. Oh, that was silly. Yeah, let me move this up a little bit. So 4,567.50. This one is going to be 4,635. This one is going to be 4,702.50. And this one is going to be 4,770. Last but not least, 4,837.50. I don't want to forget to label this, so I'm going to say total value of the investment in dollars. Now I can go up and use my data points because there's the same amount of distance between the first data point and the second point as the third data point and the second point. Okay, there's 67.50 going on every single time. You won't be able to use values like this on every graph, but since it's a linear sort of relationship, we can do that. So I'm just going to plot my points. I have a point right there. After 1 year, it's worth 4,567.50. After 2 years, we have 4,635. After 3 years, it's worth 4,702.50. After 4 years, we have 4,770. And then this one right here is where our last data point is. Now, I'm going to draw a line through all of these, and they should lay perfectly on a line, and they do. Isn't that lovely? There we go. So you'll notice that it's a linear relationship that we have. For every 1 year, we know that it goes up 6750. So let's get a little nerdy here. What's the slope of the graph? So remember, the slope is the rise over the run. So if we just visually look at it, I'm not going to get all like mathematical with the formulas, but we're running 1 and we're rising what to get to this point. So I know that the run is going to be 1 because we're moving 1 in the x direction, okay, from here to here. But to get from this data point to this data point, we have to rise what? 6750. So the slope actually tells us how much we are going to be making every year. And this is specific to simple interest. It's going to look, the graphs are going to look a little different in compound interest, but when it is simple interest, this is always the case. The slope is always going to tell us how much we make per year, and the relationship is going to be linear.